All right, so we're going to be going over School Interface 2 today. Again, this is a series, 4-part series. School Interface Challenge is kind of creating a more, a larger application with our skills so far. So just a reminder, in School Interface 1, I think I have that branched. We basically created some structures. We created a school class, we created a student class, and a staff class to kind of model data within our application. Again, as we've talked about before, yes, we could achieve all of this using dictionaries, but again, it's much cleaner and gives us more usability to use classes. So that's why we had went through that. We talked about Quarg, so this is part of our review on Friday, kind of how to read in data using the star operator to kind of convert a dictionary into keyword arguments so that we can kind of easily create our student and staff objects. Again, I know we went over that on Friday. We had a lot of great questions, but I want to make sure that we're kind of understand how we solve School Interface 1 before we proceed to School Interface 2. So let's do a quick review. I have my solution is School Interface 1. I think the pre-coded solution for School Interface 2 looks a little different, but I'm just going to go with what I had. It essentially looks the same. I made a few changes. I'm going to review that here. So we have our runner file. Our runner file simply imports the school class, and we create an instance of our school. So maybe comments are always nice. So create an instance, just get our terminology down. So we have a school instance that we created, and then we're simply printing out the staff and the students that attend this school. Nothing too interesting going on here. We just initialized Ridgemont High, but let's actually take a look at our school class because that's what we're using at the top level. So our school class looks pretty simple as well. We have only an init method right now. It takes in the name, so that's Ridgemont High in this case. It gets assigned to an instance attribute. So just again, terminology here, instance attributes that we're creating. So we're creating a few instance attributes. One is name. The other two are staff and students. Notice that we are not passing staff and students in the init method. This is data that we kind of generate internally. So the caller or whoever's creating the school instance does not have the option to even pass in like a pre-created list of staff and students. That's just not something we've designed in our interface. Now, again, if that's a need that we, a requirement that needs to be adjusted, we can obviously make that change. But right now, staff and students are simply just going to be loaded in. So I created a method called load all that exists on my staff class and my student class, and that's going to be responsible for reading in the CSV data. So we have our staff CSV and our students CSV. Those methods should read in the data, and let's take a quick look at that. Again, this is all from School Interface 1. So if I actually go to my student class, this is what I have here. Notice what's not here. I don't actually have a load all method. And so that might ring like, a question in your head, or ring a bell in your head that says, well, how can you call load all here when that doesn't exist? Now, the magic answer to that is through inheritance. So actually, I do not have no load all instance method or class method exists. Method exists here. But we're still calling that on the student class, right? So maybe split view would be better. I think that was suggested on Friday, so we'll go with that today too. Let's go over this. All right, so again, we're calling load all here, but no load all exists here. How is this going to work? Like this does work, but the magic is buried in person. So if I actually go to my person class and I need my file there, so person, if we can pull that up side by side, has a load all method. So it's actually the staff class and the student class are actually both using the same method here. And that exists in person. So let me get more space here. So this is my person class. So the person class stores a lot of the shared data. So we have name, age, password, role. But this load all method is going to be used by both my student and staff class. But the question is, well, how can I use it for both? Again, inheritance is the answer to that. So this load all method is a class method. So this CLS variable, again, that's just a variable name. We can name that whatever we choose, but CLS is the traditional name for that parameter. So this will actually point to the specific class that is calling the method. So if I call it via staff.loadall, CLS will actually refer to the staff class as a whole. It's not an instance, it's the entire class. It's the blueprint or the concept of staff. Same thing goes with student. So the magic here, I'm saying magic a lot, but it's not real magic, it's actual inheritance and OOP principles, but I'm using CLS and referring to that particular class that is being referred to. So there are two instances here. I'm calling CLS.datafile, and I'm also calling CLS and creating an instance of that class. So if I look at my students, let's pull this over here if I can. My student class, I actually define data file on the student level. So data file exists on the student level, and just to make sure we cover staff, staff also has a data file. So this points to staff.csv. The student data file points to, or is a text path to students.csv. So both of these have the same name parameter, data_file. The reason I put this in caps is to make it clear this is meant to be constant. Again, Python does not have an actual concept of constant values, but I just want to make it clear that this is not a value that should be changed. So data file right here, cls.datafile refers to either the student or staff data file based on whoever called this method. All right, so that's how I get my file path. And then I simply open up that file, alias it CSV file, and then use the dict reader object. So again, this is another example of using OOP. Dictionary reader is a class. So if I actually dive into that, notice dictionary reader is a class. This is in Python. This is nothing I've written. This is in the CSV module. Dictionary reader is a class, and we're actually creating an instance of that class right here. So again, OOP, it's going to keep coming back at us. So here, reader is an instance of a dictionary reader class. So we have an instance of dictionary reader that allows us to kind of go through each row, and each row is going to be a dictionary containing our data. And we've used the * operator to break that dictionary into keyword arguments and then create an instance right here. We create the instance and append it into people and finally return people. So again, people might be all students or all staff. We're just keeping it generic here because we're in the generic base class. All right, so that's all school interface 1. I want to make sure we have our bearings straight. Before we move on to school interface 2, were there any questions about the design for school interface 1 or anything related to this?
Yeah, I had something. So in this current class method, it's not creating a list of instances of that particular subclass, like student or staff. It's creating a list of dictionaries, right?
No, not quite. So we are creating instances right here. So it's kind of hidden. But again, when I wrote this on Friday, I broke it down into like person equals this. So that person is an instance. So the dictionary row is a dictionary of data. We use keyword arguments and create an instance using that class. So then if I put person there,
so that CLS argument is basically saying whenever you call it, it represents whatever class you're calling it from.
Yep. So this might be students.
Got it. Okay. That makes sense.
Or it could be staff. But again, since this is in the generic base class, we can't hard code staff or student because it's always going to create a staff or student object. We want to make it dynamic. So we could create a student or staff based on whoever called this method. Yep, great question. Any other questions about what we have here? Let's go with Joseph.
Would you mind going over the file path makeup a little more in depth? Like, where does each one point to, and why do we go that route with it?
Are you talking about this stuff here or the data file?
The first part you selected, the my path and file path.
Yeah, so this is basically just generating a full path so we could actually open up our file. We could do it through relative path, that works sometimes, but this is basically just taking our file, finding the base path for it, and then finding the path for our data file. I believe the reason we need to do this is because we have classes and data, which are in separate folders. So when we're in person.py, we don't have easy access to this data folder because data folder is on a different level, right? It's not nested within the same level or below. So I think we need to use a full file paths to allow person to actually get into the data folder. So that's kind of just the madness that's going on here. We just get the full base path for our current file and then find the relative path. So again, we're going up one level, we're going into the data folder and then getting the students.csv file. So all this is doing is finding the full path for that data file, and then we're eventually opening that up.
Can I ask a quick question as well? So the way that you did it here, it's different than the starter file for school interface 2. This is better because it's less code, right? Like this is a better alternative to what was the starter code in the second version.
Yeah, so yeah, this was my solution. The starter code, I think in school interface 2, again, as I mentioned, might be different. I probably should update it just to have what I'm using here. But if I go to school interface 2 is what I want. Yeah, it's gonna look a little different. It's less elegant, I would say. So we look at the student.py file that you guys are given. We have a separate objects method. So this is the load all that I have that does the reading. But if you notice this file, and if I can copy paste staff, and the staff file, this is what provided, in your school interface 2. This method and this method are nearly identical. So again, that's redundant code, as we talked about. That's usually not the best design. So I've kind of taken all the similar parts and baked them into the person class because both of them inherit from person. Now this will work. So you can use the starter file from there. I would encourage you guys to use your school interface 1 solution and basically copy that over to start your school interface 2, just because that's what you've done. I wouldn't always just kind of accept what we've given you, because that's going to be a little foreign to you. And 2, you spent the effort in school interface 1, so why not go with it if you completed it? If you didn't complete it, then you could just use our starter files. Gillen.
Hi, I'm here. I just have a very basic question. It just came to my mind when I looking at your student and staff code. They're both inherited from the person class. I wonder why it didn't use the init method that will declare the attributes from person class, or is it mandatory, or it's just optional when you inherit in class in your current class?
Are you asking why the init method for person is not used?
Correct, like in the student class or either.
Yep. So it is actually used. It's just kind of hidden. So we're actually calling it here via the super method. So remember, super is going to say, hey, what's your base class? Well, let me call that. So here, super right here refers to person, and we're calling the init method right here with name, age, password, and role. So basically the shared data is stored in person. So the way I visualize it, I'm kind of a visual person. Imagine just like a series of boxes. So person is like a small box holding some objects or some data. So we're putting name, age, password, and role into that small box. And that small box we're putting into a larger box that we call student. So student has 2 things in it. It has that small box of person that contains name, age, person, role items. But then the student box has additional piece of item that's not in the smaller box, but still inside the student box that has school ID. So that's not shared data between all users of person. So the student box holds on to school ID and holds on to a smaller box called person, which holds on to some other data. So yes, we are still calling it right here so that we could store those items in that smaller box within a box. I don't know if that visual helps, but I kind of like thinking about real physical things. Okay, I saw one more hand up before. I don't know who that was, but I want to make sure we get questions in. Jesse.
Yes, I had a quick question just to make sure on the class method that was put on the person, the one that was loaded in on the child files on the student and the staff. I guess what you put on the person makes much more sense to me as far as how it kind of goes to all the others. Is there I guess the question I'm really having is how to call those functions when it comes to those other areas.
Are you talking about how to call load all?
Yeah, like for instance, in the other one where they had the class, or sorry, the student and the staff, and they had their own method. Yeah,
Mhm.
that one. I was just trying to understand a little bit more on how those are called.
Yep. So the good thing about inheritance is that it kind of doesn't matter too much. So what I mean by that, if we go to our school file, this is the starter file. So again, sorry for any confusion there. I just wanted to use the solution that I had. But here we're calling .objects and .objects for school and staff. So I think Jesse's question, if I understand him correctly, is, well, we are able to call objects on student and staff because they exist. You know, I have an objects method on my students and an objects method on my staff. Yep, so we can call those. Again, with inheritance and just the way OOP works, even though the design I have load all on the person level. So this is in my person class. And I do not have a load all in my student class. We can still call load all here. Because basically this method is still accessible for anything that student wants to do. So this is kind of going through like two levels where we call on the student and say, hey, load all. But we realize when we get to student that no class method actually exists here. So again, this is kind of just like the purpose of OOP, or the benefit, in that we don't find it here. Python's going to say, okay, well, that's fine. I'm not going to panic yet. I'm actually going to look in your base class and see if there's a load all method. Now, if we don't find a load all method here, Python's going to be like, all right, you don't have a load all method that I can refer to. Again, Python is going to do the work for you where it says, let me search the current level. If it's not here, I'll search kind of like a deeper level to find what I'm looking for. If it finds it, great. If it doesn't, then it will yell at you and say, hey, this load all method doesn't exist anywhere in my search paths or my, where I'm trying to search for. Jake?
I thought the point of the quargs was so people could not necessarily know the order in which arguments would be passed in, and then also kind of make it more dynamic. Like, what if at some point they decide to add like advisor to the student, and what's their major? The way it's set up here, everything goes into person, is initialized in person, but you've got that hard coded in there. So it's just going to throw errors ultimately if somebody tried to add additional like keys or additional like attributes. Or did I miss the point of that? I struggled so long to figure out how to make that work without doing self.name, self.age, all that. Am I right? Is that would throw errors if someone tried to add an argument to or an extra thing to the data files?
Yeah,
Then
so
suddenly the code would break?
yes, so the code would break. So the way we're doing it right now, we're assuming that the data files are in sync with what we expect for our student file. So I think to just go with Jake's example here, probably worth exploring. I'm going to get rid of my split screen because it's taking up too much real estate. Let's go to our student file. Let's add a major. So it's going to add it at the very end, major, and then let's just say, let's put CS for all of them. Let's take study your science. Maybe change one up. Let's say this will be biology. Okay, so now we added some data here. The question is, will this actually break our code or not? Let's actually find out. So I'm going to run my code, bring up my terminal down here. We're going to run runner.py, which again creates our instances here. I'm going to do runner python runner.py. And notice we did get an error. Got an unexpected keyword argument major. So yes, with the design that I have here, this, again, if the data files change, we're going to need to change our approach here. So it won't take a whole lot. So again, we're still using quargs, which makes it kind of easy. All I need to do is say, all right, well, now we're going to accept a major here. And major is only pertinent to students, not to person, right? Because again, the two users of the person class are staff and students, right? Staff are not going to have majors. That's only something for students. So I'm going to create an instance attribute called major here and say, all right, we're going to store your major now because that's something we're accepting. So those are the only changes I need to make for the data file changing. Again, we should know what the data has, but I'll talk about maybe alternatives in a second. So if I run this now, notice it works, right? We didn't have to change too much, like our person class takes in what it wants. We just specify we're taking in something extra here. Now, again, there are alternative designs here. You could, instead of taking in each individual data here, you could take in a dictionary. So we just say, data, and then here, let's call this data dictionary. Here we need to extract out the pieces here. So again, either way, it's just, there are benefits to either way, but here, this would make it more dynamic to kind of work with, I think, Jake's example. So I'm going to kind of go along with this, but Eugene, you have a question too?
Yeah, it's a follow-up question of what Jesse just asked.
Okay.
Can you talk a little bit more about the scenarios of when to use inheritance and when to just call a function from another class directly, specifically in that student?
Sure. Yeah, we'll get, yep, definitely we'll answer that. All right. So this is another alternative design where we just pass in the dictionary and then we handle kind of picking out the data from a dictionary. Like, again, this might be better. It's all about what you think works best for your application. So if I change my student method to take in a dictionary, this makes my student class more flexible, where if I added, 12 more parameters to my data file, my student files, all that cares about is major, school ID, and the rest of the stuff I'm picking off. The rest of the extra data will be ignored. So this should still work, but I would need to change my person. Now, instead of passing in keyword arguments, I would need to actually pass in the dictionary. That's the thing that we need to change here. So accept a dictionary, because again, this is dictionary reader, gives us dictionary items. We pass in a dictionary and the class will be responsible for picking out exactly what it wants from that dictionary. Yes, that could work. And Jake, I think Jake asked the question. Yeah, that actually might be better in the case if our data file is going to change often, like if I add major and then like maybe minor, and I keep modifying my data files. Well, I probably don't want to keep modifying my code. So in this case, I would argue this design where we actually pass in a dictionary, right? That actually is more flexible. So maybe I could.
If I could ask you real quick, what I did was I thought we were supposed to pass the quargs to person, and then in person I had the quargs argument, and I used the set attribute for key in quarg set attribute. So I'm wondering if there's something dangerous in there that is happening behind the scenes that I can't necessarily see that might be a problem. But would that take any argument you pass, and it doesn't matter if it's staff or student, and it would set the key to that value, set the attribute to that value without having to go to student or staff and add the extra little thing there?
I'll be honest, you kind of lost me there. I know you mentioned set attribute and some other things with quargs. So I'm going to actually table this discussion if you don't mind. We could definitely look at it if you have questions. But let's kind of try to get on to student interface 2. We did have a question from Eugene and want to make sure we're good with everything here. Eugene, sorry, could you ask your question again? It was regarding something that was in here.
Yeah, so in the student class, I believe, like we're doing the inheritance. I'm wondering, can you give us some scenarios of when to use inheritance versus when to just call the class directly, or call the function in the class directly?
Okay, yeah, so the question is when to use inheritance. So we generally want to use inheritance when we have kind of like shared properties between classes that we're creating. So in this case, when we're creating staff and student, we realized that there's a lot of shared kind of data, which were these items here: name, age, password, and role, applied both to student and to our staff objects. So because of that, we decided to create this base class called person that kind of holds on to that shared data. The question of when to use inheritance, generally always try to use inheritance when you notice that there's like similarities between different classes you're creating. Now, you don't always necessarily should or have to use inheritance. In this case, if we had student and staff and they had no relationship whatsoever, then creating a shared base class and using inheritance would not make much sense. But I feel like maybe I'm not fully answering the question, so please definitely follow up. But again, here, we're calling a method, and we could, again, create a load all method that exists on our staff and student, right? We could create a load all method here and a load all method for staff right here too. But the reason I didn't do that is because both of what staff and student want to do are exactly the same. What they want to do is the logic that I've coded up here. Excuse me. The only difference for staff and student is the data file that we read and then the actual object that we create. So since I was able to centralize this and have one point in this logic that does the work for me, I put that into my base class. And that is, again, the benefit of using inheritance, so that, again, I don't have to duplicate this code. Like, let's say I created a third like type of person, like, I don't know, employees at the school, and employees also had a name, age, password, and role. Well, then I would need to create, that logic again. So if we go back to the seed files, like this object method exists on my staff and my student. Well, I need to copy that logic and put it into my employee class. And again, that's just kind of repeated code. And as we talked about, that's generally not the best design, because if one thing to change, well, the question is, do you want to go to all 3 of your classes and update, like, instead of using dictionary reader, you want to use something else? Or do you want to go to one central place and change it in one spot? And again, you can extrapolate that in terms of like larger projects. You might have 1,000 instances of doing something. You'd rather have that in one single central place rather than going to 1,000 different places in your project and changing those. So in inheritance, the goal of inheritance is to kind of embed shared functionality so that you can kind of reuse it kind of easily rather than having to copy and paste code often. Eugene, did that answer your question, or?
Yes, it does. Thank you.
Okay, thank you for asking a question. Shun, you have a question?
Yeah, can we look at that student class real quick? What's that dunder method do, the REPR? Is it like string, the dunder method string kind of?
Yeah, I kind of snuck that in there. I usually use str, but I realized that if you actually use repra, then if you go to your runner file, when it's printing out all the staff and students, you actually get a list if you use repra. Let's actually look at the differences, and then I'm going to get onto school interface 2. So if I run it this way with repra, oops, that's my bad. We don't want minor here. Okay, let's try again. All right, so here we're simply printing out staff and students, which is a list of staff and student objects. And this is my repra method that's printing out student Lisa, student Jesse, etc. If we actually use str here, that's not going to work. So if I change my student repra method to str, I do that. Now we get, student objects, what we normally get when we try to print out objects. So repra, it does a little bit more, it looks like. So that's why I kind of switched that from string to repra. But yeah, good question. All right, let's move on to school interface 2, because that is what we want to do today. So I'm just going to close all my files. Let's start from scratch. So this was school interface 1. Let's see what we've got to do for school interface 2. So go into my Readme, which is somewhere here. Let's go here. All right. So school interface 2, we want to create a menu. So again, this is going to allow our end users to actually interact with our application rather than having to go into our code. So we want to create a menu and give them some options. So looks like you want to list all students, view students, add a student, remove a student, and quit. These are going to be our menu options. We're not going to implement everything today for school interface 2. So we need something in our runner to show our menu. We're going to request an input from our user saying, hey, what do you want to do? Do you want to list all students? Do you want to add a student? So that's what the mode is going to be. And then we're going to have, based on what the user selects, we're going to do something with it. So I'm actually going to copy this code since they have some starter code for us. So I'm going to put that into my runner.py. All right, so we create a student, or we create a school. We don't need to print everyone out. That's been done. But we want to ask the user, hey, what do you want to do? Do you want to list all students, view a student, etc.? If they choose 1, we should list all students. So this we're calling an instance attribute, or sorry, instance method on our school instance. So we need to actually implement list students here before we try to run this, because else if we run it, it's going to say, hey, list students does not exist. What are you trying to call? So if I go into my school class, let's create a method called list students. So it's going to be an instance method. And the question is, how do we list all students? Well, the reason why this is in the school class is because we have access to students right here, right? We are storing all of our students for the school as an instance attribute. So we have an instance method that we can interact with that data and print them out. So if I do something as simple as for students in self.students, let's just print out students. I think they had a particular format we wanted. So maybe we want to do something different. I think the format was we want a number, the student name, and the ID. So there's two ways I could go about this. I could either add my str method and say, print out the student name here, and then the student ID, self.id. All right, so my str method will take care of printing out the name and ID. We want to print out the number also, right? So we'll have 1 Lisa, 2 Jesse, etc. If I go to school, so I want to print out student, but I also want to print out a number. So what if I added a number here? Let's do a F string. We want to print out number, period, and then the student. All right, so we need to have some way to keep track of number. There's multiple ways we can do this. I'm just going to do this via, let's do it through enumerate. So let's do enumerate. So this will allow my kind of index tracker to start at 1. So if I do num here, enumerate, why is this yelling at me? I'm not sure why that's yelling at me. Basically, enumerate allows me to kind of keep track of a number starting at 1. Each iteration, this will be a higher number. So it'll be num, it'll be 1, 2, 3, 4, etc. And then students should give me the students. Now I have a red line here. I'm not sure.
You just need end quotes.
Parentheses.
Thank you. All of you guys had it. Sorry. All right, yeah.
It's not a
So
comma.
now I'm printing out the number, period, and the student. And the student will go into my str method. So let's see if this works. If not, might need to look into the enumerate method. If I run Python runner hi, okay, notice we got our menu. So this menu is being generated from the code we kind of copied here. This input is going to halt our execution and wait for the user to actually input something. Now, if we input a value of 1, that should list all of our students. If we enter anything else, nothing's going to happen. We're just going to basically end our application. But let's actually enter in 1. So I'm going to enter 1 down here. List object cannot be interpreted as integer. All right, so that's my bad. Let me go to enumerate quickly. Enumerate Python. Let's go with Geeks for Geeks. All right, so I can enumerate. There's a way to start at a different index. Change start index to 2 from 0. So I do enumerate. I think that's the second parameter. So I think I switched the parameters here. That is my fault. Sorry about that. So I think I want to go self.students and start at 1 for the enumeration. Let's see if that fixes it. All right, I want to list all students. I'm going to hit 1. Student has no ID. Okay, that should be school ID. Sorry for troubles here. All right, so we want school ID because that is what exists, not ID. Always get to know what data we're working with. All right, let's try a third time, maybe the charm. There we go. So we listed out all the students, right? We got 1 Lisa, 2 Jesse, 3 Slater, etc. Again, enumerate is just the kind of the handy method where you can start a counter. This is not referencing the index, to be clear. We're not starting with the second student. We still got Lisa here, who's the first student. This number basically says, all right, your counter here, what number do you want to start at? I could start at like 400 if I want. That's just going to change the number. It's not the index, to be clear. Again, not the index. So here, list all students, option 1. That's just how we start our counter. All right, so that is listing all students that we implemented as an instance method on school. Let's look at our README, make sure we have accomplished what we want. Where's my README? There it is. All right, view. So we were able to accomplish this. I think we got that done. Release 1 is view a single student. So for our second menu option, we want the ability to enter in a student ID. And then it looks like we're creating a find student by ID instance method on our school attribute. So it's going to accept a student ID, and then we need to return the student from that method. All right, so let's get that task. So I'm going to go to, it's actually, I'm going to do some incremental commits just in case I screw anything else. I'm going to do git add everything. I'm going to do git commits completed release 0, which was the menu. All right, it's always good to have incremental commits. So I'm not going to push it, but I have that stored in my gits in case I need to come back to it. But now let's do list all or get student by ID. So I'm just going to copy this code to expedite the process. That's going to be part of our menu logic. All right, so if they select option 2, they should have another option to enter the student ID. So let's go with that. So find student by ID is the method we want. So I'm going to go to my school class, create another instance method called find student by ID. This takes in again self. You always pass in self, or you always accept self as the first parameter, because that is what Python is going to pass to your functions automatically. But in this case, we want a second parameter called student ID. And one thing that annoys me slightly, and maybe annoys you, is that we call this school ID and not student ID. I'm not sure why that naming happened, but that is the way it happened. But this is just a parameter. Again, I could call this school ID if I wanted to. In fact, I'm going to do that. So that's going to be school ID as my parameter name. So we accept the school ID. Now we need to search through our students and find if that student exists. So maybe a for loop seems sensible. Do for students and self.students. Want to search through all of our students one by one and say, hey, if student.school ID equals the school ID that we're searching for, then we found our student, so we just return our student object, right? Because we're storing all of our student objects here. We can pass back a reference for someone else to use from this method. So if I return that student, but if we get through the entire list of students that we didn't find a match, we should return something still, right? So I'm going to be explicit and return none. So whoever is going to, check the return value, they should always check to make sure they either got something valid back or they should check for none. So again, this is part of documentation. I should probably document this method saying, hey, we're going to return none if a student wasn't found, so that whoever's calling this function knows what to expect. We could alternatively raise an error, right? We talked about exceptions briefly. Student not found. That's another option if I could type correctly. But in this case, I don't want to deal with raising an exception, so I'm just going to return none. Any questions on our method here? Okay, so let's go back to our runner file. So now we should have implemented this. So we're going to print out a student. I'm not sure why str is here. I have an str method for that. So let's take a look at this. So if I go, maybe I'm going to change my logic a little bit. So let's say if students, then print out student, else maybe print out students with students. I'm just kind of adding on here again. You guys are free to add on some sensible logic. Student with a student ID not found. All right, so based on if student is none or not, if it's none, it's going to be false. That's none is a falsy value in Python. So here I want an f string that prints out student ID. All right, let's test this out. So I'm going to run Python runner. We get our familiar menu here. So what do I want to do here? I want to, let's view all student by ID. All right, so we want to enter a student ID. I actually don't remember the student ID, so let's take a look at students.csv. Let's try to find Slater. So Slater's ID is 12645. So if I type in 12645, I actually think this is going to fail. So I'm going to run this and see if I'm correct about this. So again, I'm trying to match the ID here. Will this fail? I'm not sure actually. Let's run. All right, we did find Slater. I was thinking there's going to be a string integer issue, but apparently we're storing everything as strings. So we found Slater and we print Slater's information out. But let's try this again with a student that doesn't exist, or a student ID that doesn't exist. So if I go to option 2, typing in option 2 here. All right, we need to enter a student ID. Let's go with 99999. That's not a ID that exists here. So if I've wired things up correctly, we should get a message telling me that student with ID 99999 doesn't exist. All right, so it looks like that's working. Student with ID 99999 not found. Okay, So again, we're just adding on to our school class. So previously we were just storing data. Well, now we're actually accessing that data via methods. Now, again, just an important design note, and we've talked about this before, I just want to reiterate it. It is possible for me to do this without this method, right? I could technically just copy this logic. Let's say I didn't want to create a method. I could do this out here. So let's say, comment out the method I called and put this here. I would just need to do, this would be school.students. I probably don't want that 400 there. Sorry for any confusion. That should be 1. And then we want to print out, So here, let me make this a little smaller. I could totally do this in Python. This works, right? I can access students off my school object and print out the data. But as we talked about in the past, this isn't the best approach because we're accessing data directly. Normally, you want to create methods and you want to have data in your class and methods that interact with the data yourself. So we talked about getters and setters last week, how what if we need to change the design of students somehow? Maybe it's not a list, maybe it's a dictionary or something. Well, now whoever's using our students objects, like outside of our class, well, they're gonna be like, all right, well, now I have a dictionary, my code needs to change here. Versus if this were a dictionary and we decided, hey, that needs to change, the only single place we need to change that would be in school. We're like, all right, well, now we're storing students as a dictionary. Let's change our logic in this method. But anyone outside of our class wouldn't know the difference, right? They shouldn't care how you're storing the students. All they care about is getting the data that they want. Jesse, you have a question?
Yeah, dealing with that function that you're dealing with there and how it works with the dunder method that you use in the student one. I'm just trying to connect the two in my head. So just trying to understand it.
Just to look at our str method. So we create a str method, and this method is automatically going to be called by Python when it wants to kind of display our class in terms of a string. Or basically not convert our class to a string, but represent it as a string in terms of when you're printing out to console, you're printing out a string to the console. So when we do a print statement here, we're printing out a string. So here, student is being taken as an object, but being converted to a string right here. So that conversion is handled by our str method. If this method did not exist, well, Python will be like, all right, I have some default way to display the student object. So if I commented out my str method here, we would just see that generic, object student. So let's give that a run. When I view a student, we got Slater's ID. I have a very bad short-term memory. So Slater's ID was 12645. Let's go with Screech. His ID is easy to note. So 6666. So then we get this kind of ugly looking thing if you don't have the str method. So again, str method is optional, but highly recommended if you're going to be displaying your internal data to the user. Okay, any other questions about the methods that we created? So we have list students, which lists every single student in our school. We can find a student by ID by passing in a school ID and then returning the student object if they exist. All right, I think that seems good to me. All right, so we choose option 2, define a method. Yep, we tested this out. So let's actually commit this. I'm gonna do git add, git commits, complete another release. So say completed release 1 to view students by ID. All right, so that's kind of saved in my local git. Let's move on. So, okay, so now they're asking us, well, let's make changes to our str method. So I happen to have an str method before. You guys might not have had that, but now they're asking for a formal request of how we want to show our data. So here it looks like we want to show the name in caps, then a bunch of dashed lines, age, and ID. So this is something that our str method can do for us. But I think this might change a little bit because we're using the str method for this also. So let me make those changes. So we're using the str method here. Let's actually, so let's just do exactly what they want. They want us to show student.name and student.school ID. All right, someone's going to handle that for list all students. Closing brace. But our str method should be used, when we're printing out something. So let's update our student.copy. So here, I want to format it just like they wanted me to. So let me actually copy and paste that format so I know what I'm looking at. So it should look something like that. All right, so we want Lisa in caps. I actually don't know how to convert to caps. I'm pretty sure Python has methods, so let's do a quick Google. There's some tabs here. Let's do Python convert to all caps. Let's see if Python has something. Upper, I think that seems familiar. Let's go. So I got to click on this link before. Is upper, it's not what I want. Search for upper. Let's not find that here. All right, let's keep searching. Internet's being slow, apologies. But yeah, I think there's an upper method. I'm just going to actually search for upper because that sounds familiar. So the upper method converts all lowercase in a string to uppercase and returns a modified string. All right, cool. That is exactly what I want to do here. So let's do that with our display. So we have self.name. Upper is a method we can call on a string. So that exists in Python, nothing that I'm doing here. We want a new line, so I'm going to do \n. We want a bunch of dashes. I don't know how many dashes, but probably this many. Put those in here. Then we want age. So age equals space self.age. And then we want a new line. So another new line. I mean, it doesn't look the most elegant here, but it'll show up better in our console. So we have ID equals self.school ID. All right, so we're just formatting it based on the requirements. Should look something like this. Okay, cool. So hopefully I created my str method correctly. Let's give it a spin to see if that looks like what they want. So let's do Python runner.py. All right, what do we want to do? We want to view a student by ID. I'm going to select option 2. Let's go with Screech. So 66666 was Screech's ID. I'm going to hit enter. All right, looks like I forgot a new line here. Yep, forgot a new line right here. Let's run that again. Let's actually do it with Lisa since Lisa was our example. So Lisa's ID is 13345. I'm going to view a single student, paste in Lisa's ID. So that was 13345. Hit enter. There we go. Now notice I think we should probably have more new lines here. It's all kind of condensed, but we do get the format that we want here. All right, just to clean up, again, this is my decision just because it's bugging me. What if we add a new line after their input? So, print a new line, maybe a couple new lines. Guess that'll be a couple of them. Enter student ID. Okay, but any questions on the str method that we implemented? All right, so again, yeah, str is just used for formatting. Again, it doesn't change anything about your data. It's just how you display your data to the screen. All right, so let's take a look at our README. All right, we accomplished that. I think we're done with release 2. That was pretty simple. So let's do one more commit. Git add git commit. Message is completed. Release 2. Str method for display. All right, always good to have good descriptive messages. All right, we have one more release to do, and I believe this is going to be pretty quick. We want the ability to quit, right? We want to give the option to actually escape our application. So one problem we can fix before we're done today is the fact that program quits after one action. We want the user to be able to view multiple students in the session. How can we use a loop? All right, so currently, as this kind of paragraph is hinting us to, when I run my application, let's run it again. These are my options, right? What if I want to view like 2 students in succession, right? Let's say I want to, look up one ID and then another ID. Well, the way it's designed right now, once I look up an ID, that's the end of my application. We can't do repeated step, right? If I look up Screech again, student ID was 6666. Well, I got the data I wanted, but my application's done. It's like, all right, that's all you want to do. but no, I actually want to look up, additional students. Well, how can we keep our application running so that, I could do multiple options? Anyone have any suggestions here?
You could implement a reinits. So like whatever you passing an initiation, you kind of like reinitialize it.
Could you give a little more details there?
So if you go to wherever you initialize your the actual menu, which was the runner file, where's the runner file at? Or not your runner file. Where you initialize your class. The way I do it is I basically do like whatever I pass by, I set that as self dot whatever, and then I reinitialize it within itself. So it basically creates the class again with the same parameters being passed. I don't know if I can clarify with that.
Yeah, I'm a little confused about your suggestion there. Could you kind of guide me here? What could I add here to kind of get that design to work?
So with this one, you could do you could implement a while loop for this. This one I need a while loop.
Yep.
So
While loop seems
it
good.
and then basically saying like when mode, because the input is going to be the mode. So while mode doesn't equal whatever you want it to be the quit. So in this case, it's number 5.
Yep, sounds good. So yeah, I think we're on the right track here. So while loops will run forever until this condition is met. So while this is true, my loop will continue. Once mode is going to equal 5, this condition is going to become false, right? Because mode equals 5, so this would be false. That would actually get on my while loop. So that's a sensible way to kind of keep this application running until we hit a specific condition. So here, pass, I think this should still work because we're going to get the mode, and then this will do nothing at all. I'm actually going to get rid of that. I'm sure we have that. But since we don't hit mode equals 1 or mode equals 2, that's fine. We'll loop back and we'll get mode. Like when we check the next time, if mode equals 5, we're just not going to run this loop. So let's give this a try. Make sure we quit. I'm actually going to print a nice goodbye message. So once we get down here, just say, have a nice day. Come back soon. All right, so that's going to be my exit message. All right, so let's actually give this a try. So again, this while loop is going to keep prompting the user for a menu option each time. So if I run python runner.py, mode, oh, we can't do that. We need to just have mode up here. Initialize that to none. Okay, so now we initialize a variable outside because we need to check it here. All right, what would you like to do? Let's list all students. That's one thing we are capable of doing. So I'm going to hit 1. All right, notice we get all of our students printed out. It's kind of not looking well. Why is that? I'm actually sorry. Did not intend for that, but we should be printing out the name and student ID. What's going on here? Shouldn't that print out just the number?
I think if you just print a new line underneath of that, then it'll separate it. I think it's printing out right. It just doesn't look like it is.
Yeah, I think there might be. So this is using my str method right here, but I'm not expecting it to. I'm not sure why. Right, because I just want student.name and ID. I don't want age here. So I think I'm doing something.
Is it because you're doing print instead of returning it? Returning it instead? Would that not work?
Oh, no, sorry. Because I forget that change I made. I was not calling that method. Sorry. So that's a good example of I changed something, but my caller had to change when I actually wanted to, I want to quit. So I'm gonna hit 5 to quit so I can come back here. All right, let's try that again. Sorry. I've hit 1. There, I got my students listed right here. So that's the format that we wanted. So that's option 1. But notice that my menu redisplayed. So I'm continuing my loop, right? So we hit 1. 1 is not equal to 5, so that condition is true. So we get back into prompting the user for another menu option. So let's list a student by ID. So I'm going to hit option 2. Student ID, let's go 66666. All right, notice we got our output, Screech, age 25, ID 6666. But then we're still in our application. Like this is going to continue until we hit the magic answer of 5. That's the only way we can quit. So, we can hit 3. What's going to happen if I hit 3? Notice that we hit 3, nothing happened because we don't have that functionality in our menu right now, right? We have mode 1 and 2 implemented. 3 means nothing to our application right now, but 3 also does not exit because that's not our exit condition. So we're still going to be prompting the user, like if I hit some weird number, we keep getting back to the menu. But if I actually want to quit, I would hit 5. Notice I got my goodbye message and my application actually exited. So again, hitting 5 exits our while loop and we proceed on in our application. In this case, we just print out a goodbye message and that's the end of our application. There's nothing more to do here. All right, so I think that completes release 3. While I do a git commit steps, any questions on anything that we encountered here? Elon, go for it.
Hey, Anchor, just want to clarify, is it okay to use represent method to replace all the string method, or it's more depends on the data type you're trying to like display?
Great question. I'm going to give you an answer of yes, you can replace all your str methods with repra. However, there is a difference between the two, and I'm not going to fake knowing it. They're very similar, but there's a subtle difference between them. So I would say that's a good Google question of what's the difference between str and repra. I know I've Googled it before, but I have not memorized the answer. But I usually use str just because that's what I'm accustomed to. But yeah, repra looks like it does a little bit more. Now the question is, do you want that extra, functionality or not? And that's going to be what Google is going to tell you the difference between the two. But yeah, I think just general answer, yes, you could use repra instead of str safely, and it should be fine. Okay, so I just committed it to my GitHub. Any other questions on school interface 2 here? Okay,